Hello! I'm going to try to give you guys a really quick rundown of how to model ionic bonding. This is going to help you with the ionic bonding practice worksheet. So I'm going to do an example with NaCl first, and then Li and oxygen, which is the example that's listed on that worksheet that I just mentioned that you are supposed to be completing for homework. So first things first, I'm going to start with sodium and chlorine. So the whole key to ionic bonding is we have a metal and a nonmetal. In this case, sodium is the metal, chlorine is the nonmetal. Also, I apologize for how fast I'm going to talk. I'm trying to do this in 5 minutes. So sodium is the metal. It has one valence electron. I know that it has one valence electron because it's in the first group on the periodic table. Chlorine, I know, it doesn't really like me to draw circles here, but chlorine, I apologize. Chlorine has 7 valence electrons. And I know this because it's in the 7A group on the periodic table, or group 17. Now, sodium wants to get to 8. Chlorine wants to get to 8. It's easier for sodium to lose 1 valence electron than gain 7. And it's easier for chlorine to gain 1 electron rather than lose 7. So it actually works out that sodium is trying to get rid of its electrons and give it to another element that wants electrons. So chlorine wants those electrons, sodium does not. So sodium's going to give up its valence electron. Once it gives up its valence electron, it will become positively charged, specifically 1 positive, because it gave up 1 electron. Chlorine, on the other hand, has gained an electron, which means it will have a 1 negative charge. Ionic compounds are formed when positive and negative ions get smushed together like magnets, thus creating that ionic compound, that shared electric charge there. So the Na and Cl will attract to each other because of opposite charges, thus forming NaCl. Since I only have 1 sodium ion and 1 chlorine ion, I don't put any subscripts. Now let's do one that has subscripts. So over here, I've got lithium and oxygen. Lithium has 1 valence electron, which I know because it's in the first group on the periodic table. Oxygen has 1, 2, 3, 4, 5, 6 valence electrons because it's in group 6. So lithium wants to give up its electrons, oxygen wants to gain them. Lithium will send its 1 valence electron over there to oxygen, and now lithium is perfectly happy. It got rid of its electron. But oxygen is only up to 7. 1, 2, 3, 4, 5, 6, 7. It still needs 1 more. So we need to grab another lithium, because in reality, right, there's not just 1 lithium and 1 oxygen floating around. So we're going to take another lithium atom, which again has 1 valence electron, and this lithium is going to go ahead and send its electron to that same oxygen. So both of our lithiums will have a 1 plus charge. Oops, that's supposed to be a plus. And 1 plus charge. It's not letting me write. So with both of our lithiums being 1 plus, our oxygen gained 2 electrons, so it's a 2 minus. All compounds are neutral. Super, super, super important. All compounds are neutral, which is why we know this compound works, because we ultimately have 2 positive charges right here with our 2 negative charges, and that leads to a total compound of Li2O. And that 2 is there because we have 2 different lithium ions. And that's pretty much all you need to know for drawing these arrow compounds and modeling our ionic bonding. So please let me know if you have any questions.